Good morning, dear children. In the last lecture of AC, we have studied how to find the RMS value of instantaneous EMF or current कि RMS value और peak value का आपस में relationship क्या है. What are different types of AC circuits that all we have studied in lecture number 1. So कैसे AC circuits थे एक बार रिवाइज कर लेते हैं. आपके पास में तीन कंपोनेंट्स थे द रेजिस्टर द इंडक्टर एंड द कैपेसिटर. अब अगर आप ये कंपोनेंट्स को सिंगल वे में लेते हैं सो दे विल बी मेकिंग थ्री टाइप्स ऑफ सर्किट रेजिस्टिव then inductive and capacitive. If you combine two components at a time such as RL circuit RC सर्किट और LC सर्किट्स, तो ये आपके पास हो गए टोटल 6 सर्किट्स. एंड थर्ड में हम तीनों कंपोनेंट्स को सीरीज में ले लेंगे. सो दिस विल बी कॉल्ड एज सीरीज LCR सर्किट. अब इन 7 सर्किट्स कौन कौन से हो रहे हैं. फर्स्ट इज द प्योरली रेजिस्टिव सर्किट. Second is purely inductive circuit. Third purely capacitive circuit. एक एक component आप use कर रहे हैं. Second system of pattern में आप दो दो components को combine कर रहे हैं. So the RL circuit, RC circuit और LC circuit. And third pattern में आप तीनों को combine कर रहे हैं. So that is called as series LCR circuit. Up in each of the 7 patterns, we will be connecting the respective components with an AC EMF, जिसमें sinusoidal pattern होगा और sine curve के according alternating current और EMF will be changing. So the first topic is different types of AC circuits. So in this section, we will derive voltage and current relationship. That what is the relationship between E and I for individual as well as combined circuit. Individual means ये तीन individual circuit हुए resistive, inductive and capacitative और ये चार combined circuits हो गए carrying a sinusoidal current, and we assume the capacitor and inductor as ideal unless otherwise specified. ठीक है, जब तक आपको बोला नहीं हो तब तक आप कैपेसिटर एंड इंडक्टर मींस C एंड L कंपोनेंट्स को आइडियल ही लेकर चलेंगे. तो सबसे पहला सर्किट डायग्राम है आपके पास प्योरली रेजिस्टिव सर्किट when AC voltage is applied to a resistor. So which is also called as the purely resistive circuit. So check the figure. In this case, we have connected a pure resistor of the value capital R in series with an AC source of EMF E, where E is the instantaneous value of EMF and it is given by E equal to E0 sine omega t. So this is equation number 1 according to the textbook. Now check. In this equation, the different terms are E0 is the peak value of the alternating EMF. So आप note करते जा सकते हैं बेटा. E0 is the peak value of alternating EMF means maximum value, and omega is the angular frequency which can also be given as omega equals to 2 pi f, where f is the frequency or 2 pi divided by t, where capital T is the time taken for one complete AC cycle. Now, if we apply just Ohm's law, we get that the potential difference across the resistance can be represented as E is equal to IR, which we can take. Suppose this be equation number 1, so this be the equation number 2. Now, instantaneous value of EMF is equal to instantaneous value of potential drop. So we can equate the RHS of both the equations. Hence, this is IR equal to E0 sin omega t. ठीक, अब यहां से आप फाइंड कर लेंगे द वैल्यू ऑफ करंट, चेक कर सकते हैं। करंट आई में हम लोगों ने कोई भी सब्सक्रिप्ट यूज नहीं किया, सो दिस कैन बी द इंस्टेंटेनियस वैल्यू ऑफ एसी करंट। सो आई इक्वल टू E divided by R if you consider just equation number 2 by Ohm's law, and if we put the value of E, this is E0 sin omega t divided by R. Now dimensionally अगर हम consider करें तो left hand side current value carry करता है, तो राइट हैंड साइड भी करंट वैल्यू ही कैरी करना चाहिए। Now sin omega t is dimensionless, so the dimensions of E0 upon R should be equal to that of the current. So we can say that I equal to I0 sin omega t, where this be equation 3, and we can assume that I0 equal to E0 divided by R. So we can compare this equation by again Ohm's law. So we can check that the behavior of a resistor is similar for AC as well as for DC. Means resistor basically क्या करेगा? रेजिस्टर बेसिकली करंट को रिड्यूस करेगा एंड इट्स बिहेवियर विल बी सेम फॉर अल्टरनेटिंग करंट और द डायरेक्ट करंट. नाउ इफ वी कंसीडर द प्रीवियस इक्वेशंस वी कैन चेक दैट for a resistor, we have taken the first equation as E is equal to E0 sin omega t, and we also obtained I equal to I0 sin omega t. So you may check from equation 1 and 3 that sin omega t is single. It means what? There is a phase difference of 0 radian between E and I, that is between instantaneous value of alternating EMF and instantaneous value of alternating current. ठीक है, तो इस तरह से आप इनको फेजर डायग्राम में भी रिप्रेजेंट कर सकते हैं. इट मीन्स वॉट, both, that is EMF as well as I will reach the minimum value and the maximum value at the same time respectively. So this we can study with the help of a graph, which is also called as the graph between E and I. So if we observe the equations of EMF and current again, E is equal to E0 sin omega t and I equal to I0 sin omega t, we can check that there is no phase difference between the respective angles. Both are omega t. Hence, when the EMF will be 0, omega t is 0, then EMF will be 0 as well as simultaneously current will be 0. So both are starting at the same time. Now when omega t becomes pi by 2, the instantaneous EMF becomes maximum and holds the value E0. On the same time, simultaneously current becomes maximum and holds the value I0. सो इनके ये दोनों वैल्यूज एक दूसरे को ओवरलैप करते हैं बट बाय सम डिफरेंस, तो आप बोल सकते हैं कि दोनों के बीच में फेज डिफरेंस 0 है. अब जैसे ही आपने दोनों इक्वेशंस में वैल्यू ऑफ एंगल पुट किया पाई, सो अगेन बोथ टेक द वैल्यू 0, मतलब मिनिमम हो जाते हैं. फिर यहाँ पर आप आ जाते हैं 3 पाई बाय 2 के केस में, both are taking maximum values but in opposite directions, and in the case of angle 2 pi, both are again taking the values 0. So this is the graph of E and I versus omega t for purely resistive circuit. ठीक है, अब नेक्स्ट आते हैं हम फेजर डायग्राम में कि हाउ टू ड्रॉ द फेजर डायग्राम फॉर अ प्योरली रेजिस्टिव सर्किट. So in the AC circuit which contains resistance only, Current and voltages are in the same phase. This we have studied just now with the help of graph. Hence, both phasors for I and for E are in the same direction, making an angle omega t with OX, that is with X axis. So, their projections on vertical axis, that is Y axis, give their. सो आप जैसे ही फेजर से y एक्सिस मींस वर्टिकल एक्सिस पर प्रोजेक्शन ड्रॉ करेंगे एज शोन इन द डायग्राम इट विल बी गिविंग अस द इंस्टेंटेनियस वैल्यू. जैसे सबसे पहले आपने इक्वेशन लिखा E इज इक्वल टू ई जीरो साइन ओमेगा टी. So let's I am taking an example. E is equal to suppose 70 sin omega t. तो E0 की वैल्यू means the maximum value has 70 वोल्ट न्यूमेरिकल वैल्यू. अब आपने 70 वोल्ट के पीक से जैसे ही y एक्सिस पर एक परपेंडिकुलर ड्रॉ किया तो आपको E मींस इंस्टेंटेनियस वैल्यू मिल जाता है फॉर पर्टिकुलर टाइम t. And similarly, if we get the equation I equal to 10 sin omega t means it carries the maximum value of current as 10. एंड जैसे ही आपने यहाँ से y एक्सिस पर परपेंडिकुलर ड्रॉ किया तो आपको फिर से इंस्टेंटेनियस वैल्यू मिल जाती है. सो दिस इज द phasor diagram for a purely resistive circuit. Now let's solve a numerical based on purely resistive circuit. Now let's check a solved numerical in Maharashtra State textbook page number 291. An alternating voltage given by E equal to 140, that is 140 sin 3142t is connected across a pure resistor of 50 ohm. So सबसे पहले हम compare कर लेंगे given data को. So the given equation is E equal to 140 sin 3142t. Let this be equation number 1. इसको आप कंपेयर करेंगे आइडियल इक्वेशन ऑफ इंस्टेंटेनियस ईएमएफ से. सो दिस इज E इज इक्वल टू E0 sin omega t. So we can compare that the maximum value of EMF is 140 volt and the value of angular frequency is 3142 radian per second, obviously the unit. And the value of capital R, that is the resistance, is 50 ohm. Now we have to find the frequency of the source. सबसे पहला क्वेश्चन है आपके पास कि आपको फाइंड करना है F. As we have compared, omega is equal to 3142 radian per second, we can write this omega as 2 pi f, and this can be written as 3.142 into 100 to convert it into pi. So this is pi. So pi will cancel and we get the answer for f equals to 50 hertz. So this is answer to question number 1. Now second question is we have to find the RMS current through the resistor. So for this we will be observing the original equation where the peak value of EMF is 140 volt. The equation was 140 sine 3142t. The value of resistor given in the question is 50 ohm. So first we will again compare it with the ideal equation ओमेगा टी, तो आपको मिल जाता है कि पीक वैल्यू ऑफ ईएमएफ है 140 वोल्ट. So peak value of current by Ohm's law will be E0 divided by R. So this is equal to 140 divided by 50. तो आप आंसर जब निकालेंगे इसका पीक वैल्यू ऑफ करंट का 0 will cancel and this is equal to 2.8 ampere. But we have to find the RMS value of current, which is equal to I0 divided by root 2. So this is 2.8. 1 by root 2 हम लोग previous lecture में cover कर चुके हैं. This is equal to